Lyra is a small constellation. It is one of 48 listed by the 2nd century astronomer Ptolemy, and is one of the 88 constellations recognized by the International Astronomical Union. Lyra was often represented on star maps as a vulture or an eagle carrying a lyre, and hence sometimes referred to as Aquila Cadens or Vultur Cadens. Beginning at the north, Lyra is bordered by Draco, Hercules, Vulpecula, and Cygnus. Lyra is visible from the northern hemisphere from spring through autumn, and nearly overhead, in temperate latitudes, during the summer months. From the southern hemisphere, it is visible low in the northern sky during the winter months. The lucida or brightest star Euro, and one of the brightest stars in the sky Euro is the white main sequence star Vega, which forms a corner of the summer triangle. Beta Lyrae is the prototype of a class of stars known as Beta Lyrae variables. These binary stars are so close to each other that they become egg-shaped and material flows from one to the other. Epsilon Lyrae, known informally as the double-double, is a complex multiple star system. Lyra also hosts the Ring Nebula, the second discovered and best-known planetary nebula. History. In Greek mythology, Lyra represents the lyre of Orpheus. Made by Hermes from a tortoise shell, it was said to be the first lyre ever produced. Orpheus's music was said to be so great that even inanimate objects such as trees, streams, and rocks could be charmed. Joining Jason and the Argonauts, his music was able to quell the voices of the dangerous sirens, who sang tempting songs to the Argonauts. At one point, Orpheus married Eurydice, a nymph. While fleeing from an attack by Aristaeus, she stepped on a snake that bit her, killing her. To reclaim her, Orpheus entered the underworld, where the music from his lyre charmed Hades. Hades relented and let Orpheus bring Eurydice back, on the condition that he never once looked back until outside. Unfortunately, near the very end, Orpheus faltered and looked back, causing Eurydice to be left in the underworld forever. Orpheus spent the rest of his life strumming his lyre while wandering aimlessly through the land, rejecting all marriage offers from women. There are two competing myths relating to the death of Orpheus. According to Eratosthenes, Orpheus failed to make a necessary sacrifice to Dionysus due to his regard for Apollo as the supreme deity instead. Dionysus then sent his followers to rip Orpheus apart. Ovid tells a rather different story, saying that women, in retribution for Orpheus's rejection of marriage offers, ganged up and threw stones and spears. At first, his music charmed them as well, but eventually their numbers and clamor overwhelmed his music and he was hit by the spears. Both myths then state that his lyre was placed in the sky by the Muses. Vega and its surrounding stars are also treated as a constellation in other cultures. The area corresponding to Lyra was seen by the Arabs as a vulture or an eagle carrying a lyre either enclosed in its wings, or in its beak. In Wales, Lyra is known as King Arthur's harp, and King David's harp. The Persian Hafiz called it the lyre of Zura. It has been called the manger of the infant Saviour, Praeceps Salvatris. In Australian Aboriginal astronomy, Lyra is known by the Barong people in Victoria as the Malifaux constellation. Lyra was known as Urkuchile by the Incas and was worshipped as an animal deity. Characteristics: Lyra is bordered by Vulpecula to the south, Hercules to the east, Draco to the north, and Cygnus to the west. Covering 286.5 square degrees, it ranks 52nd of the 88 modern constellations in size. It appears prominently in the northern sky during the northern hemisphere's summer, and the whole constellation is visible for at least part of the year to observers north of latitude 42°S. Its main asterism consists of 6 stars, and 73 stars in total are brighter than magnitude 6.5. The constellation's boundaries, as set by Eugenie Delporte in 1930, are defined by a 17-sided polygon. In the equatorial coordinate system, the right ascension coordinates of these borders lie between 18 hours 14 m and 19 hours 28 m, while the declination coordinates are between plus 25.66 a degree and plus 47.71 a degree. The International Astronomical Union adopted the 3-letter abbreviation Lyre for the constellation in 1922. Notable features: Stars equals. The brightest and by far the most well-known star in the constellation is Vega, a main sequence star of spectral type A var. Only 7.7 pascs distant, is a delta Scuti variable, varying between magnitudes of 0.02 and 0.07 over 0.2 days. On average, it is the second brightest star of the northern hemisphere and the fifth brightest star in all, surpassed only by Arcturus, Alpha Centauri, Canopus, and Sirius. Vega was the pole star in the year 12,000 BCE, and will again become the pole star around 14,000 CE. Vega is one of the most studied of all stars, and has been called arguably the next most important star in the sky after the Sun. Vega was the first star other than the Sun to be photographed, as well as the first to have a clear spectrum recorded, showing absorption lines for the first time. The star was the first single main sequence star other than the Sun to be known to emit X-rays, and is surrounded by a circumstellar debris disk, similar to the Kuiper belt. Vega forms one corner of the famous summer triangle asterism. Along with Altair and Denb, these three stars form a prominent triangle during the northern hemisphere summer. Vega also forms one vertex of a much smaller triangle, along with Epsilon and Zeta Lyrae. Zeta forms a wide binary star visible in binoculars, consisting of an M star and an F-type subgiant. The M star has an additional close companion, bringing the total number of stars in the system to 3. Epsilon is a more famous wide binary that can even be separated by the naked eye under good conditions. Both components are themselves close binaries which can be seen with telescopes to consist of A and F-type stars, and a faint star was recently found to orbit component C as well, for a total of 5 stars. In contrast to Zeta and Epsilon Lyrae, Delta Lyrae is an optical double, with the two stars simply lying along the same line of sight east of Zeta. The brighter and closer of the two, Delta II Lyrae, is a fourth magnitude red bright giant that varies semi-regularly by around 0.2 magnitudes with a dominant period of 79 days, while the fainter Delta I Lyrae is a spectroscopic binary consisting of a B-type primary and an unknown secondary. Both systems, however, have very similar radial velocities, and are the two brightest members of a sparse open cluster known as the Delta Lyrae cluster. South of Delta is Gamma Lyrae, a blue giant and the second brightest star in the constellation. Around 190 pascs distant, it has been referred to as a superficially normal star. The final star forming the Lyre's figure is Beta Lyrae, also a binary composed of a blue bright giant and an early B-type star. In this case, the stars are so close together that the larger giant is overflowing its Roche lobe and transferring material to the secondary, forming a semi-detached system. The secondary, originally the less massive of the two, has accreted so much mass that it is now substantially more massive, albeit smaller, than the primary, and is surrounded by a thick accretion disk. The plane of the orbit is aligned with Earth and the system thus shows eclipses, dropping nearly a full magnitude from its third magnitude baseline every 13 days, although its period is increasing by around 19 seconds per year. It is the prototype of the Beta Lyrae variables, eclipsing semi-detached binaries of early spectral types in which there are no exact onsets of eclipses, but rather continuous changes in brightness. Another easy-to-spot variable is the brighter Lyrae, north of the main asterism. Also known as 13 Lyrae, it is a fourth magnitude red giant semi-regular variable that varies by several tenths of a magnitude. Its periodicity is complex, with several different periods of varying lengths, most notably one of 46 days and one of 64 days. Even further north is FL Lyrae, a much fainter ninth magnitude algal variable that drops by half a magnitude every 2.18 days during the primary eclipse. Both components are main sequence stars, the primary being late F-type and the secondary late G-type. The system was one of the first main sequence eclipsing binaries containing G-type star to have its properties known as well as the better studied early type eclipsing binaries. At the very northernmost edge of the constellation is the even fainter V361 Lyrae, an eclipsing binary that does not easily fall into one of the traditional classes, with features of Beta Lyrae, WSC majores, and cataclysmic variables. It may be a representative of a very brief phase in which the system is transitioning into a contact binary. It can be found less than a degree away from the naked eye star 16 Lyrae, a fifth magnitude A-type subgiant located around 37 Pascs distant. The brightest star not included in the asterism and the westernmost catalogued by Bayer or Flamsteed is Kappa Lyrae, a typical red giant around 73 Pascs distant. Similar bright orange or red giants include the fourth magnitude Theta Lyrae, Lambda Lyrae, and HD 173780. Lambda is located just south of Gamma, Theta is positioned in the east, and HD 173780, the brightest star in the constellation with no Bayer or Flamsteed designation, is more southerly. Just north of Theta and of almost exactly the same magnitude is Eta Lyrae, a blue subgiant with a near-solar metal abundance. Also nearby is the faint HP Lyrae, a post-asymptotic giant branch star that shows variability. The reason for its variability is still a mystery. First catalogued as an eclipsing binary, it was theorized to be an arbitrary variable in 2002, but if so, it would be by far the hottest such variable discovered. In the extreme east is Ara Lyrae, the prototype of the large class of variables known as Ara Lyrae variables, which are pulsating variables similar to Cepheids, but are evolved population II stars of spectral types A and F. Such stars are usually not found in a galaxy's thin disk, but rather in the galactic halo. Such stars serve as standard candles, and thus are a reliable way to calculate distances to the globular clusters in which they reside. Ara Lyrae itself varies between magnitudes 7 and 8 while exhibiting the Blasco effect. The easternmost star designated by Flamsteed, 19 Lyrae, is also a small amplitude variable, an Alpha Tucanum Venaticorum variable with a period of just over 1 day. Another evolved star is the naked eye variable XY Lyrae, a red bright giant just north of Vega that varies between 6th and 7th magnitudes over a period of 120 days. Also just visible to the naked eye is the peculiar classical Cepheid V473 Lyrae. It is unique in that it is the only known Cepheid in the Milky Way to undergo periodic phase and amplitude changes, analogous to the Blasco effect in Ara Lyrae stars. At 1.5 days, its period was the shortest known for a classical Cepheid at the time of his discovery. W and S Lyrae are two of the many Myra variables in Lyra. W varies between 7th and 12th magnitudes over approximately 200 days, while S, slightly fainter, is a silicate carbon star, likely of the J-type. Another evolved star is EP Lyrae, a faint arbitrary variable and an extreme example of a post-AGB star. It and a likely companion are surrounded by a circumstellar disk of material. Rather close to Earth at a distance of only 16 Pascs is Gliese 758. The Sun-like Pomeri star has a brown dwarf companion, the coldest to have been imaged around a Sun-like star in thermal light when it was discovered in 2009. Only slightly farther away is V478 Lyrae, an eclipsing RS Canum Venaticorum variable whose primary star shows active star spot activity. One of the most peculiar systems in Lyra is MV Lyrae, a nova-like star consisting of a red dwarf and a white dwarf. Originally classified as a VY Sculptoris star due to spending most time at maximum brightness, since around 1979 the system has been dominantly at minimum brightness, with periodic outbursts. Its nature is still not fully understood. Another outbursting star is I Lyrae, an SUSE Majoris-type dwarf nova that has undergone several superroot bursts. Of the same type as V344 Lyrae, notable for an extremely short period between superroot bursts coupled with one of the highest amplitudes for such a period. The true nova HR Lyrae flared in 1919 to a maximum magnitude of 6.5, over 9.5 magnitudes higher than in quiescence. Some of its characteristics are similar to those of recurring novae. Deep sky objects equals M57, also known as the Ring Nebula, and NGC 6720, has a diameter of 1 light-year and is at a distance of 2,000 light-years from Earth. It is one of the best-known planetary nebulae and the second to be discovered. Its integrated magnitude is 8.8. It was discovered in 1779 by Antoine Darquea, 15 years after Charles Messier discovered the Dumbbell Nebula. Astronomers have determined that it is between 6,000 and 8,000 years old. It is approximately 1 light-year in diameter. The outer part of the nebula appears red in photographs because of emission from ionized hydrogen. The middle region is colored green. Doubly ionized oxygen emits greenish-blue light. The hottest region, closest to the central star, appears blue because of emission from helium. The central star itself is a white dwarf with a temperature of 120,000 Kelvin. In telescopes, the nebula appears as a visible ring with a green tinge. It is slightly elliptical because its three-dimensional shape is a torus or cylinder seen from a slight angle. It can be found halfway between Gamma Lyrae and Beta Lyrae. Another planetary nebula in Lyra is Abell 46. The central star, V477 Lyrae, is an eclipsing post-common envelope binary, consisting of a white dwarf primary and an oversized secondary component due to recent accretion. The nebula itself is of relatively low surface brightness compared to the central star, and is undersized for the primary's mass for reasons not yet fully understood. NGC 6745 is an irregular spiral galaxy in Lyra that is at a distance of 208 million light-years. Several million years ago, it collided with a smaller galaxy, which created a region filled with young, hot, blue stars. Astronomers do not know if the collision was simply a glancing blow or a prelude to a full-on merger, which would end with the two galaxies incorporated into one larger, probably elliptical galaxy. A remarkable long-duration gamma-ray burst was GRBO 50525A, which flared in 2005. The afterglow re-brightened at 33 minutes after the original burst, only the third found to exhibit such an effect in the time frame, and unable to be completely explained by known phenomena. The light curve observed over the next 100 days was consistent with that of a supernova or even a hypernova, dubbed SN 2005 NC. The host galaxy proved elusive to find at first, although it was subsequently identified. Exoplanets in orbit around the orange subgiant star HD 177830 is one of the earliest exoplanets to be detected. A Jovian mass planet, it orbits in an eccentric orbit with a period of 390 days. A second planet closer to the star was discovered in 2011. Visible to the naked eye are HD 173416, a yellow giant hosting a planet over twice the mass of Jupiter discovered in 2009. And HD 176051, a low-mass binary star containing another high-mass planet. Just short of naked eye visibility is HD 178911, a triple system consisting of a close binary and a visually separable Sun-like star. The Sun-like star has a planet with over 6 Jupiter masses discovered in 2001, the second found in a triple system after that of 16 Cygni. One of the most studied exoplanets in the night sky is TRES-1b, in orbit around the star GSC 02652-01324. Detected from a transit of its parent star, the planet has around 3/4 the mass of Jupiter, yet orbits its parent star in only 3 days. The transits have been reported to have anomalies multiple times. Originally thought to be possibly due to the presence of an Earth-like planet, it is now accepted that the irregularities are due to a large star spot. Also discovered by the transit method is WASP-3b, with 1.75 times the mass of Jupiter. At the time of his discovery, it was one of the hottest known exoplanets, in orbit around the F-type main sequence star WASP-3. Similar to TRES-1b, irregularities in the transits had left open the possibility of a second planet, although this now appears unlikely as well. Lyra is one of 3 constellations to be in the Kepler mission's field of view, and as such it contains many more known exoplanets than most constellations. One of the first discovered by the mission is Kepler 7b, an extremely low-density exoplanet with less than half the mass of Jupiter, yet nearly 1.5 times the radius. Almost as sparse as Kepler 8b, only slightly more massive and of a similar radius. The Kepler 20 system contains 5 known planets. 3 of them are only slightly smaller than Neptune, and 2, while the other 2 are some of the first Earth-sized exoplanets to be discovered. Kepler 37 is another star with an exoplanet discovered by Kepler. The planet is the smallest known extrasolar planet known as of February 2013. In April 2013, it was announced that of the 5 planets orbiting Kepler 62, at least 2 Kepler 62e and Kepler 62Φ are within the boundaries of the habitable zone of that star, where scientists think liquid water could exist, and are both candidates for being a solid, rocky, Earth-like planet. The exoplanets are 1.6 and 1.4 times the diameter of Earth respectively, with their star Kepler 62 at a distance of 1,200 light-years. Notes. References.